Hi everyone, I'm now going to do question 15 from exercise 10E. I will go through this whole problem, but it would be really great if you could pause it throughout and see if you can have a go at attempting to solve it without looking at the whole video first, but see how you go. All right, so a regular pentagonal garden is to be constructed with side lengths of 20 meters, which we can see here. Find the width of the land D required for the plot. So we want to find from here all the way down to here. Now, with a pentagon, a key bit of information you need to know is that a pentagon, all of its interior angles add up to 540 degrees. So if this is a regular pentagon, what that means is that all of these angles will be the same size. So the way I would work out the size of one angle, if I go 540 divided by 5, I get 108 degrees. So this one angle here is 108 degrees. So remember, we're doing right angle triangle trig, so what I really want to know is the size of this little angle here, so I can make my right angle triangle. This angle is going to be half, so I'm going to then go 108 divided by 2, which would get me 54 degrees. So this little angle here is 54 degrees. I know that this length here is going to be half of the 20, so this length here is 10, and I'm looking for this length here, which we'll call x. Alright, so if I'm thinking of my trig ratios, I've got my opposite and my adjacent, so I'm going to be using tan. I've got tan theta equals opposite over adjacent. Tan 54 equals x over 10, and I want to move the 10, so I'm going to times it by 10 here and times it by 10 here, and x is going to be about 13.7 meters. Now, you might think at this point that you would just double this because they look like they're the same, but they're actually not, because this height here on this triangle here is actually that height there. So we actually need to do a whole different equation to work out, let's do purple, this length here. So the angle here is still going to be 54. This length here is still, this length here is still going to be 10, and this length here, is going to be the 13.7. And what we want, so now if we label the sides, we have here opposite, here we have adjacent, and here this now becomes, because our right angle's here, this actually becomes the hypotenuse. So I can either use cos or sine. For this one, I'm going to use cos with my adjacent side. So I've got cos theta equals adjacent over hypotenuse, or you could do sine theta is opposite over hypotenuse, but I'm going to do this one. So I've got cos 54 equals 10 over hypotenuse. So I want my hypotenuse moved to the other side, so I'm going to times by the hypotenuse and times by the hypotenuse here. So I've got h times by cos 54 equals 10. Now to move cos 54, I'm going to divide it by cos was 54 on both sides. So now it's h is 10 divided by cos 54. And when I put this part here into my calculator, I get 17.01 meters. So to work out the height of D, therefore D is going to be equal to x plus h, which is 13.7 plus 17, which is approximately 30.7 meters. And that's how you do question 15.